Okay, this is Geometry Section 2.3, Inductive Reasoning, and also Law of Detachment and Law of Syllogism. Let me start by saying this is an extremely weird chapter in a math book. It talks about reasoning skills. You won't get answers like x equals 2. You're going to get answers like that is an example of the Law of Detachment. That is an example of the Law of Syllogism, valid, invalid. So it is a different chapter, it is a different section, so let's talk about them. In geometry, there's two types of reasoning. There's deductive reasoning and there's inductive reasoning. When you're using deductive reasoning, you're using facts, definitions, and properties to reason. You're also using scientific research to make conjectures, and a conjecture is basically, again, an educated guess. Deductive reasoning is based on solid fact, things that are known to be true, things that we accept true as human beings. Inductive reasoning is using patterns to make a conjecture, to make your guess. You're going to observe something, and what we're saying is that's enough to make an educated guess as to what will come next. Inductive reasoning is observational. So I have some examples here, and we're going to pick out whether we think it's inductive or deductive. The first one, a chemistry experiment produces the same results 20 times. You conclude that it will always produce the same results. Since we haven't actually written any types of laws or theorems, this is simply an observation. This would be observational. That would be a form of inductive reasoning. Tim is Veronica's cousin. Since David is Veronica's twin brother, Tim is also David's cousin. That's a known fact. That's a known fact. So that is also a known fact. That is solid fact. That's definitely deductive reasoning. The school librarian notices that many students are requesting books about different countries in Africa. The librarian concludes that one of the social studies classes must be studying about Africa. Definitely observational. Definitely inductive. Julie notices that each term in a sequence is 1, 3, 9, 27, is found by multiplying the previous term by 3. She concludes that the next two terms are 81 and 243. And for this one, I kind of have it's 50-50, because if she actually writes a formula found by multiplying, maybe she says the formula is 3n. When you plug in a number, like if you plug in a 1, you'd get out the first term 3. You plug in a 2, not including 1. If you plug in a 2, you multiply by the next term. If you can actually write a formula, it could be deductive. I'd say half and half. It might be inductive. It might be deductive. I think it's pretty observational, though, so I'm going to write inductive. This one, given the sequence, you conclude the next term is 35. Haven't written any type of formula. Haven't done anything formal with it. That one's definitely inductive. You looked for a pattern, and you noticed a pattern, and you made an observation. We know that all men are mortal. Since John is a man, John is mortal. Fact, fact, fact. Deductive. All of the people that you meet in a town are very strange. You conclude that everyone in the town is very strange. Definitely observational. Definitely inductive. Okay, that's the first part. Second part. There are two funky laws that you need to know about. Law 1 is called the Law of Detachment. And it says this: if a conditional statement is true, all you need is a true hypothesis to get a conclusion. So, my example, if you are a deer hunter, then you own a rifle. What the Law of Detachment says is, given a true hypothesis, if I know that part is true, I can conclude that part. So I'm going to give you that I am a deer hunter. Mr. Koulis is a deer hunter. The conclusion you could come up with is that I will own a rifle. Mr. Koulis owns a rifle. That is a valid statement. Here's the one that's kind of weird, the one you will miss on your quiz. If you are a deer hunter, then you own a rifle. I'm telling you that Mr. Koulis owns a rifle. I'm telling you that I own the rifle. I'm telling you the end. I'm telling you the conclusion. if given the conclusion, you cannot go back and assume the hypotheses. So Mr. Coolis is a deer hunter is an invalid statement. You must be given a statement, given a hypothesis, come up with a conclusion. You cannot be given a statement, given the conclusion, come up with a hypothesis. That's why that's invalid. And the last one is Law 2 is called the Law of Syllogism, and it's kind of a funny word, but it says you can string true conditional statements together and create a new statement with the hypotheses of the first and the conclusion of the last. Here's an example. I'll show you that on Monday. But my example is, if I am a gamer, then I like Fortnite. I take that part and I use it at the beginning of the next one. If I like Fortnite. Then I forget to eat. If I forget to eat, I take that part. If I forget to eat, then I get hungry. And the last one, if I get hungry, then I eat Fortnite burgers. If I string them, the first to the second part goes to the third. I take that part, I put it here. The third part goes to the fourth. I take that part, I put it there. The fourth part goes to the fifth. If I've strung them together, I can say, if I am a gamer, the first part of the first statement, then I eat Fortnite burgers, which is the last part of the last statement. The conclusion of all of this by the law of syllogism, if it's strung together correctly, if I am a gamer, then I like Fortnite burgers. So here's some examples of that. Only one of these is right. If thunder, then cats. If cats, then smurfs. If smurfs, then ducks. Therefore, if cats, then ducks. That is not correct. This part should be here. If frolf, then golf. If golf, then tennis. If track, then hurdles. If frolf, then hurdles. That would work, but I didn't use the end part here, there, so also not right. If oompa, then loompa. If loompa, then elfie. If elfie, then reindeer. Therefore, if oompa, then reindeer. That is correct. A to B, B to C, C to D. Therefore, the first part to the last part, and it works.